I created a programming language from scratch. Unsafe 4-bit is a fast-paced, compiled, interpreted, dynamically typed, imperative procedural programming language on top of another programming language. UFB is kind of similar to its lower-level counterparts because it tries to manage its memory even if it technically does not. With UFB, you can manage your 1 by 256-byte memory tape. The freedom of using the non-ROM 218 bytes gives you the ability to shoot yourself in the foot like how you would manually manage memory in lower-level languages. The built-in ROM includes the space literal, capital A to Z, numbers from 0 to 9, and the line feed, also known as the new line character. UFB includes 16 default commands such as write var, null var, trim, add, subtract, multiply, divide, no operation, jump more, jump less, jump equal, jump not equal, print, and read. Write your first program full of commands, get disgusted by the colored warning and error messages, and compile and run the program. So how did it get here? Step number 0, get bored. Step number 1, choose a programming language to build on top. Hey, choose JavaScript. So I went to Java. The syntax of our new language is quite simple. All you have to do is pick one command from the default 16 and then add the necessary arguments. Most commands need proper memory indices to operate, but some needs non-memory indices to operate. In other words, those commands need actual integers typed by the programmer to work. Got it? Okay, sure. The actual first step is to write the compiler. A compiler is something that compiles something into something else. Each command has its 4-bit equivalent. I have to add the padding for a quick performance boost, but let's not talk about that. Once we have a part of the compiler set up, we have to tell the programmer where they did the worst of themselves. There are two types of logs, warnings and errors. Warnings are those logs that you can ignore but will have dire consequences in the long run. Errors are those that will kill the compiler before it gets to write to the output binary file. The hard part is creating a performance and memory-wise interpreter. It all starts with reading the compiled file. Reading everything with a mapped byte buffer all at once will only double the memory usage. Not just that, it will affect the performance in a pretty bad way, since not all the bytes will be used anyway because of the enormous effects of jump statements. So, I decided to make it read what it needs and ultimately skip those that are conditionally useless. After all that, we have to find a performance-wise way of telling the interpreter which command is which. So I chose a switch statement. A switch statement is as fast as asking someone, which of these is a circle? Now that we know which is which, we could just run a performance-wise method tied to the command itself. When you see the code as that menacing beast in the UX department, everything you see is slow. The optimization phase took out a week of my life just so that it would go like that. In other words, I tinkered with every single method I could find just so that the performance would be like running a program in Java. The project is on GitHub, but that doesn't mean you could modify everything in a split second. It's under the case of the GNU Public License version 3. That's because it's way longer than its predecessor and is much clearer. Lastly, it has everything I could ever want from an open source license. The conditions are already displayed, so try it out in the description below.